For this problem, I wanted to do an example where you had to look at a system of masses and then break them apart to look at internal forces that once you break the masses apart can be considered to be external forces. What I'm talking about here is when we think about these masses, they actually are all exerting equal and opposite forces on each other. You know, like mass 1 exerts a force on mass 2, and mass 2 exerts a force back on mass 1, and so on. But when we look at the system as a whole, all those internal forces cancel out, and we don't have to consider them. If we then look at some of these masses in isolation, we will consider those forces. So let's get started. For part A, we want to find the acceleration of these blocks. They're just being subjected to a single force of 51 newtons. So I'm going to look at the entire system. And that means all three blocks together. I'm looking at the forces in the x direction. Oh, and I did make this a little simpler. I didn't deal with any friction. So the only force we have is that F, and that's equal to the sum of all the masses times their acceleration. So the acceleration can be found by taking that mass and divided by the total, taking that force, and divide by the total mass. And we find that this system is accelerating with a rate of 3 meters per second squared. So now we're going to sort of look more internally of these blocks. So we're going to look for part B. We want to find the force that block 1 exerts on block 2. Sorry, that's supposed to be an on. So our picture would change because now we just want to look at those two blocks, and the force that's applied to block 1 would not appear in this force diagram because it's on block 1, it's not on 2 or 3. I'm just doing these normal forces in weight just as an example of just practicing recognizing forces. They don't really play a role in this problem because we're looking at horizontal acceleration. Now the force that's on 2 is the force that 1 exerts on 2. And these things are still accelerating at a rate of 3 meters per second squared. They all have to accelerate at the same rate. So that's not going to change. When we look at the forces in the x direction and how they cause some acceleration, now the force that's responsible is that force that block number 1 exerts on block number 2. It's going to accelerate blocks 2 and 3 with that acceleration that we know. So this ends up to be 2 plus 10 times the 3. And so that's 36 newtons is our force that 1 exerts on 2. So that's part B. Now let's look at C. We're going to only look at block 3 because we want to figure out the force that 2 exerts on 3. And that's an internal force if we have the blocks together, but if we only consider block 3 alone, the reason actually that it gets accelerated is because 2 pushes into 3, and we're trying to figure out what that force is. So let's see what the force is that really accelerates 3. And so we're only accelerating mass 3. It's accelerating with a rate of 3 meters per second squared. And so that gives us a force of 30 newtons. And so that is our answer to part C. All right, hopefully that's a helpful example.